All right, welcome back. Now we're gonna talk about the ultrasonic sensor. I'll show you how to hook them up and program it. All right, so this guy is pretty cool. Basically, how this works is you got four pins on this one. So if you look up close, uh, GND is ground, so it's our negative 5 volts. VCC is positive 5 volts, so it's going to be your red wire. So those are two wires there, and then you have trigger and echo. So those are now this one gets two signal ports. It gets two signal ports instead of the one signal port like the servo motor. This one gets two signal ports because basically one of these, so that this is T and this is R. So it's transmit and receive. So the way that this works is it sends out an ultrasonic wave, um, which is T. So it transmits an ultrasonic wave. It'll send a it'll transmit an ultrasonic wave out, and then it'll hit something and then bounce back, and then the receive will receive that. So that's why you need two pins there. Uh, one to send out and one to receive back, and then it measures the time that it takes to do that, and then it'll give you a distance in the Arduino program. So the way that we're going to hook this up is you're going to need four wires. I like to use red, as we've previously discussed, for uh, the positive 5 volts or VCC. And then for ground, you need the negative. Boom. Just like that. And then you need two more. For my ultrasonic sensors, I like to use blue and green. You could use whatever colors you want, though. Just stay consistent. Boom. And then green. Boom. Okay, so if we look at our Arduino, just like before, this is going to go into 5 volts. That's our positive plus 5 volts. The negative 5 volts or ground is going to go to the ground terminal. And then you need to plug the ultrasonic sensor into two digital PWM pins. So any of the pins from 2 to 13. For this example, we'll just select uh, 8 and 9. All right, so now let's hop into the Arduino program and I'll show you how to program the ultrasonic sensor. These things are pretty cool. Hey guys, welcome back. Okay, now I'm going to show you how to program the ultrasonic sensor. So you're going to need a new library. So we're going to go to Tools, Manage Libraries. Takes a second to pop up here. And so the library that I like to use for these ultrasonic sensors, they're kind of prone to having like misreadings, but I use this one library and it works super well. So it kind of removes all of those errors. So if you type new ping, new space ping, thing is so laggy. Should be the top example. I already have it installed. It's telling me that in this blue font here. But if you don't have it installed, you just hit this install button, and that should come with all the examples that we're going to reference. So now let's open an example of the code, just like before, and sort of understand what's going on here. So if you do File, Example, and then you go to New Ping, scroll all the way down until you see New Ping, and then it should be New Ping. Let's do Example. All right. Okay, so let's go over this. Just like before, these comments are just communicating to you some notes. It says, example new ping library is a sketch that does a ping about 20 times per second. That's really fast. That's going to be plenty for us. So just like the servo library, we have like this hashtag include. That's just bringing in our new ping library so we can use all of those functions within our code. So I don't know why, but some programs will define, instead of writing like int trigger pin 9 equals 9 semicolon, they'll do this like hashtag define and then space and then in all caps create a new variable and then space and then write a number without a semicolon. This is the equivalent of like int LED equals 8 that we did before, right? But for whatever reason, this is the way that they do it. I don't really know what the difference is. It's just another way to define variables, basically. So they've done hashtag define trigger pin. So basically, for these two lines, they're defining what pin we're talking to on the Arduino. So I'm just looking on the sensor right now. My trigger pin was blue, and I put blue on 9, and then green runs to 8. Echo green. So echo green runs to 8, and trig pin blue runs to 9. The way that we've done our ultrasonic sensor, trigger pin is going to be 9, and then we're going to do echo pin 8. So let's change this 10 to an 8. And then they've defined another variable, which is max distance. So they say maximum distance we want to ping for in centimeters. So I guess maybe the sensors are calibrated for like a certain range or distance. So I'm not going to mess with this. They probably know what they're doing. New ping. So new ping is we're creating a new variable for our ultrasonic sensor. This is just like my servo. You remember servo, my servo? This is the same thing, but for the ultrasonic sensor. The way that they've done this is they say new ping, and then sonar is like the equivalent of my servo. It's just a variable name. You could probably name this anything you want. This is going to take 3 arguments to define the function. So the first one is the trigger pin, which we've already defined up here, separated by a comma. The second one is the echo pin, which we've also already defined up here. And the third one is max distance, which once again, we've defined all up here. So they make it super easy. We're basically just creating a new function named sonar and this is basically going to do the actual pinging. We don't have to do any work. Anytime we want to like get a distance to something, all we have to do is type sonar as a command, which is super nice. So next, we're going to talk about serial.begin. We're going to talk about what goes on in the void setup. So this is everything, once again, that's going to run only once. So we haven't seen this line of code yet. This is serial.begin and then like this long number here. I'll explain that more in a second, what that is. But basically, there's going to be like a little window within our Arduino IDE that's going to give us like live feedback for how far away things are from the sensor. And this is just like how frequently you're communicating to that window. So let's go over the void loop for now. So all this is doing is it's basically pinging out to the sensor. The way that the sensor works is it's sending out like a sound wave, and the sound wave is going to hit something, and then it's going to bounce back, and then the sensor is going to receive that signal, and it's going to measure the time it takes to hit something and come back, and then given that amount of time, it can convert it to a distance measurement. So if something is closer, it's going to take less time to come back. If something is further away, it's going to take more time to come back. And between the library and the sensor, it's smart enough to do the math to tell us exactly how far away things are. So you start the loop by delaying 50 milliseconds, and then you have some interesting lines here. So this is serial.print, then you have serial.print sonar.ping_cm, and then you have serial.print lncm. So I know this is a little confusing. Let's plug in our program and I'll show you like exactly what's going on and you'll understand it a bit better. All right, now we're going to upload the program to the Arduino. Once again, make sure you have the correct board and port selected. If you're copying me, it should be the Arduino Uno, and then you should have a port that's not COM1 and it'll pop up. You click upload. Once your software has uploaded, we're going to hit this magnifying glass icon in the top right. And you may be seeing some like question marks and like weird symbols. This is the line that I was talking about before. So if you change this like middle box on the bottom right, it might be on like 9600. If you match it to that number we had in void setup, so 115200, it should update and be communicating the right information. So that's what this line of code is. You're communicating this is called the baud rate, or like I think it's basically how fast the Arduino is like communicating information to this little like terminal window, basically. So that's all this line of code is doing. So now let's recognize what's going on. I'm going to turn off auto scroll for a second so it just slows down. Very quickly, all of these numbers are just like showing up rapidly. So what's going on here? Let's think about it. So each separate line is it says ping in front of it with a colon. So that's exactly what this line is. It's saying serial.print is saying, okay, tell the serial monitor to create some text. So it says open parentheses, and then within these quotation marks, you can basically type any text that you want, and then you end it with a semicolon. So that's all that they're doing here. They're saying create a new line in the serial window that with like words or letters that says ping colon. That's all this line is doing, the first line. Then the second line is saying, okay, now instead of printing just like the same text over and over again, print whatever you ping in this. So now we're calling the actual function. This is what's like bringing about the number that we're seeing. So you see 66, 67, whatever. This is what like is doing the actual hard work. Sonar.ping underscore cm. So we're calling the function that we've defined previously up here. We're saying ping dot ping and return it in centimeters. Open close parentheses, and then you end that function. And then serial dot print. This one's a little bit different. This has ln. So ln means after this line is done, make a new line. So this is basically just throwing, this is the same thing as ping colon. You're just like creating text that occurs in the serial monitor. And CM is going at the end of the line. And then because we have LN, it says, okay, basically do like a return or like create a new line after the CM. So that's all that's going on here. So let's run through it quickly one more time. You use a delay of 50 milliseconds. I think this is because like you can't tell the sensor to like ping like every millisecond. Like it needs some time to like do the actual calculation. So that's what the delay is for. And then it's saying put text on this screen that says ping colon. And then this line is do the actual like hard work of pinging and then do the math and then produce a result of whatever distance you're measuring. And that's what produces the actual like number, the 2-digit numbers you're seeing here. And then this last line says at the end of the numbers, throw on CM just as a unit and then LN in after print. You know how you notice how this third line is different than the previous two. The LN just means, okay, now after the text that we've created, just create a new line. And that's all that's going on here. So now let's do something kind of important. So let's put our hand close to the ultrasonic sensor that we have. And we're going to notice that as we do that, the numbers start to change. So for my ultrasonic sensor, like if nothing's in front of it, it's just reading like 46 centimeters. This may be like a larger or smaller number for you, but this basically means that nothing's in front of it. So let's remember that, okay, if nothing's in front of the ultrasonic sensor, the value that's returned is going to be like somewhere in the 40s. So if we put our hand somewhat in front of it, let's recognize what's going on. So some value is being returned. That's like, I don't know, it's like 9, 10 in the teens, you know? Somewhere above, let's say 5 and below 20 is like what's being returned. So we've recognized that if our hand is not in front of the ultrasonic sensor, a far away reading is 47, or for me, it's like in the 40s, right? And then when my hand is close to the sensor, it's somewhere between 5 and like 20, right? So that's going to be important for later. Let's just put that in the back of our heads for now. But that's all that this software is doing, right? It's pretty interesting because you get to see live feedback of what your sensors is picking up. And we didn't need that much code, right? We just are communicating with the serial monitor to as like a visual representation to us, like what's going on and what's going on with the sensor. This one line because of this nice new ping library, is doing all the hard work for us. It's doing all the math, doing the calculations to give us the distance measurement, and then it's just reporting back in this serial monitor window.